Over 2,000 years ago, Euclid showed every number has exactly one prime factorization, which we can think of as a secret key. It turns out that prime factorization is a fundamentally hard problem. Let's clarify what we mean by easy and hard by introducing what's called time complexity. We have all multiplied numbers before, and each of us has our own rules for doing so in order to speed things up. If we program a computer to multiply numbers, it can do so much faster than any human can. Here is a graph that shows the time required for a computer to multiply two numbers. And of course, the time required to find the answer increases as the numbers get larger. Notice that the computation time stays well under 1 second, even with fairly large numbers. Therefore, it is easy to perform. Now compare this to prime factorization. If someone told you to find the prime factorization of 589, you will notice the problem feels harder. No matter what your strategy, it will require some trial and error until you find a number which evenly divides 589. After some struggle, you will find 19 times 31 is the prime factorization. If you were told to find the prime factorization of 437,231, you'd probably give up and get a computer to help you. This works fine for small numbers, though if we try to get a computer to factor larger and larger numbers, there is a runaway effect. The time needed to perform the calculations increases rapidly as there are more steps involved. As the numbers grow, the computer needs minutes, then hours, and eventually it will require hundreds or thousands of years to factor huge numbers. We therefore say it is a hard problem, due to this growth rate of time needed to solve it. So factorization is what Cox used to build the trapdoor solution. Step 1. Imagine Alice randomly generated a prime number over 150 digits long. Call this P1. Then a second random prime number roughly the same size. Call this P2. She then multiplies these two primes together to get a composite number N, which is over 300 digits long. This multiplication step would take less than a second. We could even do it in a web browser. Then she takes the factorization of n, p1 times p2, and hides it. Now if she gave n to anyone else, they would have to have a computer running for years to find the solution. Step 2. Cox needed to find a function which depends on knowing the factorization of n. For this, he looked back to work done in 1760 by Swiss mathematician Leonhard Euler.